ledger. What is a ledger? I have given you an example of a ledger here. It is set of transactions. Let's say you go to a grocery store, you buy vegetables for $15. So the ledger entry will be you are paying the vegetable owner $15. And then vegetable guy, let's say go to a doctor and he pays money for, let's say, some medicine. Let's say he pays $10. So then it will be like vegetable owner paying to pharmacy $10. So it's just a set of transactions. This is more like your bank account. In bank account, let's say you have $2,000 deposit for your salary, and then 500, let's say you spent on mortgage. So what is left with you? Well, $1,500. So ledger is set of transaction. At the end, you have your account balance. So that's all that Bitcoin is. So here I have shown you a sample ledger, and this ledger might have millions of transactions. So in Bitcoin world, the Bitcoin ledger stores all transactions that has happened since Bitcoin was invented. So that will be millions of transactions. So you need to store them in blocks, because storing them continuously in one continuous memory location is not possible. So if you have studied linked list in your data structures, in linked list you have one node and then you have an address to the second node. So it is similar to that. You have blockchain where you have block 1, block 2, block 3, and these are just the block size of Bitcoin is 1 megabyte. So in 1 megabyte you store some transaction, then you move to next block for further transaction, and these blocks are linked together. Now Bitcoin protocol has some security mechanism to avoid fraud, for which we need to go little into cryptography. So what is cryptography and what is cryptographic hash function? So let's look at that. Let's say you have a function like this. If I ask you to make a guess on x, will you be able to? Well, it's an easy one. X is 4. So this is a function in which you can guess input based on output very easily. There are certain functions where guessing input based on output is little difficult. For example, here, which two numbers will add up to 9? Well, it could be 4 and 5, 3 and 6, or maybe 9 and 0. I have a typo here, 0 and 9, so B should be 9. So this is little difficult to guess. Not very difficult, but little difficult. In cryptography, there is a function called SHA-256, where you give an input string and it will generate a hash. You know, if you know about hash function, this is just a hash function. It will generate a hash which is 256 bit long. In terms of hexadecimal, it will be 64 hexadecimal digits. This is impossible to guess. If I give you this kind of hash to make a guess on X, it's close to impossible. The only way you have is you trial and error. You try different strings and try to see, you know, which one produces the desired output. So I'm going to show you a couple of SHA sample strings. So let's say if you have ABC, the SHA for that will be this. It will be 64-bit hexadecimal number, but I'm not showing the complete number. That's why I have a dot dot dot. When you change any character, let's say you change C to D, the whole hash will change. So you cannot make any guess. It's like totally random. But every time you call SHA-256 on ABD, it will produce the same output. So that way it is deterministic. But guessing it the other way is very, very difficult. Here is simple Python code. You write only 3 lines of Python code to produce SHA of any string. And SHA-256 is a cryptographic hash function for the reason we already discussed. So in Bitcoin or in a blockchain, the actual block is not only transaction, it has couple of more component. So it has block number, it has the previous hash, and then the Bitcoin protocol is such that you convert this whole block into a string. So let's say you take block number, transaction, previous hash, you make it a string, and you supply that string to SHA-256 function, and that will produce a hash. Now the protocol requires that first few digits of this hash should be 0. How many digits? Well, it changes time to time. Right now I think it's 30 digits, but at some point when it started it was less. So let's say we are saying that first 4 digits of the hash should be 0. So that is our difficulty level. So you need to add. Now see, if you just convert this to a string and create a hash, the hash might not have first 4 zeros. So you have to introduce a new element called nonce. Nonce is like number ones, and add this number to a string and see if this can produce a hash which has first 4 digit as 0, because here our difficulty level is 0. Now let's say this doesn't produce that hash. So then you have to make a guesswork. You have to change nonce to 2. Check it. Is it first 4 digit 0? No. Then change it to 3, 4. So you have to do a lot of guesswork. You are running almost like a for loop and guessing it. So try it like for loop, which starts from 1 to, let's say, it goes all the way to trillion or trillions of trillion number. And your end goal is to produce a hash where first 4 digit is 0. It is simple, right? Let's say I come to this number in my for loop and my hash becomes first 4 digit is 0. Then you can say that this block is verified or this block is confirmed. And the process of guessing a nonce is Bitcoin mining. So here we said it's first 4 zeros. In reality, it will be like first 30 zeros, 60 zeros, depends time to time. And all these miners, they are not doing any rocket science. They are not doing any algorithmic work, guys. You can also do Bitcoin mining. We'll write the code right now after this theory session. It's very simple for loop where you are trying different nonce and trying to figure out a hash where first X number of digits are 0. So for doing Bitcoin mining, these miners get a reward. In 2009, if you mine one block, you will get 50 Bitcoins. Every 4 years, the reward gets half. So right now in 2020, the reward is 6.25. Okay. In 2024, it will be half of this. And Bitcoin's value today is $28,000. So you would think, oh, 28 into 6,000. This is so much money. Anyone can do it. And you are right. There are thousands of people who are doing Bitcoin mining. But the thing is, this guesswork, it seems easy, but we'll see in the code. It's very time consuming. It's not difficult algorithm wise. The code is simple, but it takes a lot of computation power, electricity to get to the right guess. And if 10 people are doing guess, whoever makes the correct guess first, that person will win the reward. Let's say I make a guess. After 10 minutes, other person is making guess. That person doesn't get a reward. So that's the theory. In the end, the blockchain looks like this, where every block will have a reference to previous hash. So you see this block 2 has this previous hash, you see 003A. And as more and more transaction gets added, this blockchain becomes more and more longer. It's like a chain. So more and more blocks get added, and people who are miners who are making this nonce. So again, just to repeat, all you are doing is making a guess on this nonce. So let's get into coding now. I have opened my PyCharm community edition and I have created this file where I have imported hashlib module so that I can use SHA-256 function. Now I'll go into my Zen meditation mode so that there are no distractions. So first, let's try this SHA-256 function and see, what it gives. So I'm just giving a random string here and I'm saying, all right, run this code. Well, it's saying Unicode objects must be encoded. So what you need to do is you need to say encode this thing into ASCII, and okay, actually you need to encode the actual string, into ASCII, and that will give you SHA-256 object. Now if you want to get the actual hash out of it, then what you need to do is you need to say dot hex digest. Okay, so that will give you the actual 256 bit. So if you count these digits, it is 64, but this is hexadecimal and each hexadecimal digit is 4 bits. So this is actually 256 bit or 64 bit in terms of hexadecimal. So now I have this function, so I'll create a nice utility function so that I can make use of that. So SHA-256 text, and then I will just return this. So instead of ABC, supply the input text. Okay, and if underscore underscore name is equal to underscore underscore main, so this is my main Python entry point, and I will try to call 256 SHA-256 function, and looks like this is working fine. Now what we need to do here is, in order to do mining, first we need to have transactions. So let's create some dummy transactions. So let's say my transactions are, let's say Dhaval is giving Bhavin, who is my brother, let's say 20 Bitcoin, and Mandalorian is giving Kara, his friend, 45 Bitcoin. Okay, and I need to now write a function called mine, which will take these transactions. So the mining function will take transaction and couple of more parameters and generate a new hash, and this is the hash that we want. So I will print that new hash here. Okay, all right. Now, other than transactions, what are the input parameters of mining functions? Well, let's go back to our function and see. In our let's go back to our presentation. That's what I mean. So in our presentation, we saw that the hash is nothing but SHA-256 called on this whole string. So what is this whole string? It has a couple of things. It has block number, it has transactions, it has previous hash, and nonce is something which you are just guessing. Okay, so these are the parameters that our function need. So I will pass all these parameters. I also have prefix zeros. So in our presentation, prefix zeros were 4. In real life right now with Bitcoin, the number of zeros are actually 20. So we'll pass this as a parameter. Okay, so let's say block number I want is 5, just making something up. Transaction is transaction, and let's say the previous hash was, and I'm doing copy paste just to save some time. Let's say previous hash was this. Okay, and my difficulty is nothing but number of zeros that you want in front of your hash. Let's say it is 4. So then I supply my difficulty. Okay, using all of this, we need to produce the SHA-256, which has first 4 digit as 0. So let me hard code my nonce to be 1, and then I will produce my text. So my text is what? Block number, and block number is integer, so I need to convert it into a string. Transaction is a string, previous has is a string, and nonce is a number, so convert it into a string. I get the whole string of the entire block, on which I call SHA-256, and that is my new hash which I return from this function. Okay, so let's first try it with nonce to be 1. So when I run it, see, I get this hash, but my first 4 digits are not 0. So then I try nonce 2. They are still not 0. I tried 3. Now do you think I will keep on trying different nonce? Well, no. If you are not a dumb programmer, you will obviously write a for loop. So you will say for nonce in range. What is my range? Okay, let's talk about that. Let's say some max number. Okay, what is this max number? Well, depends on your computation power. I mean, you can have literally like infinite loop, up to you. But I will restrict it to some big number. And for that, run a for loop where you are trying different nonce and trying to produce new hash. Now, new hash should have first four digits as 0. How do you check that? Well, see, here I am passing prefix 0 as 4. Okay. So in so I'm going to open idle. I mean, I generally when I'm coding, I open idle to try different things. So let's say I have some string. Let's say some hash. Okay. This Python has a function called starts with. So if you do 2, 3, 4 starts with, it will say 0. But if you do something else, right? It will say false. So I want to check if this string starts with first 40. It doesn't start, so it says false. Now how do I check 40? So I have, see, in this function I'm supplying a number. So from number 4 I want to get string 4. So that is easy way. You will say 0 multiplied by 4, and that will give you the prefix. You see, it's a simple Python string operation. So you will say my prefix string is number of prefix zeros. So prefix zeros and 0 into prefix zeros. Okay. And when your new hash is computed, you check if new hash starts with my prefix zeros, not prefix zeros, prefix string, then return new hash. Now, of course, when you get to this point, you have won a big reward. So you want to print that, that, yeah, I mined the block. Okay. I mined the block and earned 6.5 Bitcoin after iterating this for loop for so many times. Okay. This is my nonce. And after iterating this for a long time, even if you don't get anything, then you can raise an exception. Normally, as I said, you will run an infinite loop until you get an answer, or you run a for loop until you exhaust your computation budget. So then you will raise an exception saying, okay, this is too much work, it's not profitable. I'm earning Bitcoin, but on top of that, my electricity and my hardware cost is going up. So I'm raising an exception. Okay. So now we are ready to run this. Let's run our mining code. So see, this mining happened very fast. So it was able to run the for loop 2425 times and found the hash which has first 4 digits as 0. The moment you increase the hash size, the difficulty size, it will take long time. It's gonna take long time. So I'm going to add a code to measure the time it takes to mine a given block. Okay. So see, it took some time, but I don't know how much time. So let's add some timer code. Again, I'm gonna do some copy paste work to save our time. So you can import time module in Python. When you say time.time, it gives you current time. Okay. And then you do your mining, and after you're done with your mining, you find out the total time by doing this. So here I am taking timestamp at this given instance, subtracting it from start time. That gives me the total time it took for mining in seconds. And I will print that. So let's run it. So it is mining now, and it is taking some time. We'll know how much time it is. It took 12 seconds to find the answer, but you kind of get an idea that Bitcoin mining is nothing but a guesswork. It is like playing online game. If you win, you get certain reward. Now, you might be thinking, well, it is still not bad. I have my computer. I wrote this code, and can I win like Bitcoins using this? Well, you can. But the thing is this. Right now, the difficulty level of Bitcoin, this prefix zeros is 20. So if I change this to 20 and run the code, it might take even 1 year to mine this Bitcoin. You understand? It's very difficult. So um, Bitcoin mining requires special hardware. So let me just do Google and show you some of the things. So if you do Google Bitcoin mining hardware, you will find this kind of special devices. These are like, special ASIC machines which people have, which Bitcoin miners keep. They have like data centers where they keep not one such machine but hundreds of such machine, and they try to make this guess faster. It's like who can guess this faster and who is lucky. So let's say I guess it, and after 5 minutes if you guess it, you don't get a chance, you lose. Whoever uh, comes first in the guessing game wins that Bitcoin. So now let me show you the some of the actual Bitcoin block. So when you do Google Bitcoin Explorer, you will find this website where you can see the real Bitcoin blocks. These are all the blocks. So now let me click on this block. The height means which block. So it's like block 1, 2, 3, 4. Bitcoin has been trading for so many years. So right now it is 664,000 block. Now look at this hash. So this is the difficulty level I was talking. This is 20 zeros. So right now Bitcoin difficulty level is 20 zeros. If you Google Bitcoin block 1 or Bitcoin Genesis block, you will find the first block ever that was created. This was created by Satoshi Nakamoto, who invented Bitcoin. At that time, the number of zeros were only 8. So it was not very difficult. And at that time, you will get 50 Bitcoin as a reward. Now, Bitcoin's value in dollar was very less at that time. Right now, the reward you get is 6.25 Bitcoin. But Bitcoin's value is close to $28,000 as of 2nd January 2020. So you see why people have so much hardware, so much resources for doing mining. So that's all the code I had. If you look at these lines, this much, I'm excluding this caller code, but if you look at these many lines, it's less than 15 line of code that you need to mine the Bitcoin. So it is very simple actually. The real difficulty is who can make the guess first. And as I said, try the difficulty level 20 or 30, okay? And you will see it will take long time. By the way, you might get lucky and you might find the answer easily, because it also depends on your transactions and number of other factors. But in general, the Bitcoin mining is a difficult thing, not in terms of the actual code. We just saw the code, it was very easy, but in terms of running the actual computation. I hope you like this video. If you do, share it with your friends. Also write this code and post in LinkedIn that you mined a Bitcoin, because you really did. And if you have any other questions, please post in a video comment below. As I said, I'm working on a very simple explanation based on analogy, where I will explain how Bitcoin, blockchain, cryptocurrency works in a simple language. As of this recording, that video is not available, but in future, after maybe 2-3 weeks, it will be available. And whenever it is available, I will post the video link in a video description below. So make sure you check the video description just in case that video is available. That's gonna give you a lot of understanding of how Bitcoin works in a very simple, stupid, easy language. All right. Thank you for watching. Bye.